Okay, kiddos, it's been a while since I've seen all of you, and I hope everything is going well and everyone's staying healthy. I really do miss you guys. I'm sure you guys are kind of enjoying this vacation, but I do miss seeing you guys in class. I am going to record some tutorials now that we are in this for the long haul, and hopefully it helps you with your sections. And you can still ask questions and whatever you may need, but hopefully you will not need to after watching these tutorials. So we are going over section 9.3, Arcs and Chords. We are going to pretty much just work the relationship between arcs and chords inside of a circle. If you haven't figured it out already, chapter 9 is on circles. That is the shape that we are going over. Okay, so I'm going to kind of just skip through these example problems. What would be really helpful is if you have the PowerPoint pulled up and you're following along with it as we go over this. Okay, so concept 1. If you notice in my PowerPoints, the ones that I've sent out on Google Classroom, I try to put these slides in to let you know when a new concept is coming up. So this is the first concept in section 9.3. And here is the concept. We're going to use congruent chords to find arc measures. And then we'll have example problems and theorems. So you also need to have your cheat sheet handy and by you. So our first theorem that we are going to go over is the corresponding chords theorem. All right, or minor arcs theorem. I can't remember which one, how I named it in your cheat sheet. But what it says is if you have a circle, okay, 2 of these minor arcs in this circle, all right, so that means arc AB and arc BC will be congruent, okay? 2 minor arcs are congruent if and only if their corresponding chords are congruent. So here's your example. That should be in your cheat sheet, what I just read. This is your example that you write down. You draw this, write this. Arc AB is congruent to arc BC if chord AB is congruent to chord BC. So if these 2 chords are congruent, then these minor arcs are also congruent. And it works both ways. When I say if and only if, that means I can also flip the direction and say if if arc AB is congruent to arc BC, then the 2 chords are congruent. So it can go both ways. So you need to draw this visual and then write this down. This is the explanation that you need to see. All right, so let's look at some examples of this theorem. All right, hopefully you can see this. I'm losing light here, but hopefully, let me look. Hopefully you can see this okay. All right, so I'm just going to look at example problem 1, and you guys will start getting the hang of this. I see a circle, and the 2 chords are congruent. Chord AB is congruent to chord DC. So because the chords are congruent, their arcs are also congruent. So in order to solve for x, which is what the directions are asking me to do, I'm just going to set them equal to each other. 3x is equal to x plus 4. And then I would solve. I'd subtract my x and move it over here. So I'd get 2x equals 40. So x is 20. All right, now this second one is kind of the biconditional. It is the opposite direction, okay? So here I see my arcs are congruent. Arc AB is congruent to arc BC. So because these 2 arcs are congruent, the chords are congruent, and I would just set them equal to one another. I'd move my x's to one side, get my constants to a side, and I would solve for x. Same with 3. Now, I don't see numbers here for these arcs, but I see the tick marks. So by looking at this, I know that arc MN is congruent to arc PQ. Because the arcs are congruent, the chords are. And then this is me working it, if you can see it. Let me see. It's so hard doing this. Okay, so I just set the two equal to each other. I've moved my X over, and then I move my constant over, and I got X equals 6. All right, so let's just keep moving because I'm losing light. Okay, so here's some more examples. Once again, here I see that my chords are congruent because of these little tick marks here. So because my chords are congruent, my arcs are. So I would set 3x equal to 147, and I would get that x is 49. Here, I see that my arcs are congruent, okay, because I see the tick marks, and because they're congruent, the chords are congruent. And here is my work. Hopefully you guys are figuring this out, okay? All right, now the next example is just a little word problem, but it's not difficult. It says a circular piece of jade is hung from a chain by 2 wires wrapped around the stone. JM, maybe pencil would be better. JM is congruent to chord KL. The measure of arc KL is 90, okay? So that arc is 90 degrees, and they want me to find the measure of the arc JM. Now, just a little quick side note, I guess. This symbol right here means arc. This is chord. You guys should know this. We've worked this all year. But this little symbol right here stands for arc. And you have to know what they're talking about, because you see you have a chord JM, but you also have arc JM. So you need to pay attention to those symbols, okay? So, I mean, we should know this by now. If these two chords are congruent, then their corresponding arcs are. So if KL is 90, arc JM is also 90 degrees. The end, okay? And here's just the couple, this is the next slide that just shows you that. It explains it, okay? And then here's the example problem you just do on your own. It's just called guided practice, okay? You do it on your own. But it's the same type of problem as up here, okay? All right, moving on. Second concept. Now we're gonna use congruent arcs to find chord lengths, which I had already included some example problems for this in concept 1. Okay, so we're just gonna keep practicing. This is just still more practice for that theorem. All right, so if we're looking here, this is a little different because they're not the same circle. But in the theorem, it said that this theorem, that the congruent chord or the congruent arc theorem applies to if the circles are congruent also. So if circle A is congruent to circle B, I'm going to look at the chords, all right? I don't know if the chords are congruent, but they do have minor arcs associated with them who are congruent. So if arc WX is congruent to arc YZ, then their two chords are congruent. Okay, so in order to solve for them, I'm just going to set 7x minus 2 equal to 5x plus 6 and solve. And I showed the steps, so you can just use those steps and answer it. Okay, once again, example 2. I have two congruent circles. The arcs are congruent, so I'm going to solve for the chords. So I'm just going to set them equal to each other. So this works if the two chords are in the same circle. Let me go back to that. Okay, if they're in the same circle, like this example, okay, and it also applies to if they're in separate circles, but these circles have to be congruent. And if they are congruent circles, then that theorem still applies. Okay. Next concept, use a radius perpendicular to a chord. So we have a new theorem coming up, okay? What this says is if I have a diameter, so that means they have to state that it's the diameter or I have to see that it is, okay? If I have a diameter of a circle and it's perpendicular to a chord, then that diameter bisects the chord and it bisects its arc, okay? So once again, they have to tell me it's the diameter or I have to see it, And I have to see this little 90-degree angle. It has to be perpendicular. Okay, so I have to see that it's a diameter, and I have to see that it's perpendicular to another chord in that same circle. Okay, and then it also works backwards. So if I have two random chords in a circle, and one is a perpendicular bisector of the other, then that first chord is a diameter. So this second theorem just kind of states if it's a diameter. This one tells you it is, this one states that it is, if all of those conditions are met. If it's a perpendicular bisector to the other chord, then the first one is a diameter, okay? I hope that makes sense. Here's your visual, here's your explanation you need to write in your cheat sheet. Okay, so let's look at some examples. All right, so here I have a circle. It tells me that arc DEF is 150, okay? So this arc DEF is 150 degrees. They want me to find the measure of arc DE. So they want me to find the measure of just this smaller arc, okay? All it tells me is that radius EG is perpendicular to chord DF. So because EG bisects angle DEF, okay? All right, let me go back. So if this radius EG is a perpendicular bisector to this chord, then it's bisecting this chord and it's bisecting this angle. So EG, because it's bisecting this chord and it's perpendicular, then it's also bisecting that arc, okay? So if this arc is cut in half equally and the whole thing is 150, I'm just gonna divide 150 by 2 and I get that that little arc is 75 degrees. All right, same here. This was kind of your guided example problem for you just to work on your own. It tells me that arc WUX is 160, all right? And looking at my circle, I see that these two chords are perpendicular. So if they are perpendicular, then this chord is being bisected equally, as well as the arc. So I would just divide 160 by 2, and I get that it's 80. All right, next concept. Now we're going to use a diameter that's perpendicular to a chord, okay? So here is a ceramic tile, all right? Now this concept's a little trickier, not too bad, but we're going to have to go back on our knowledge of right triangles, okay? So it says this ceramic stepping stone below. The diameter AB is 18 inches long. So this entire diameter right here is 18 inches long. And chord EF, so this chord right here, I'm going to try to mark it so you guys can see. Chord EF is about 8 inches long, okay? So this entire chord right here is 8 inches. They want us to find CD. So they want us to find this little part of the diameter. Okay, so I'm going to flip to the next one. All right, I pulled it back right here. All right, so remember AB is 18 inches. All right, and what did it say? EF was 8 inches. Okay, they want me to find CD. So they want me to find this little part of the diameter right here. Now, what I'm going to have to do, hopefully you can see what's happening here. If I'm working a right angle right here, I can draw, okay, so I'm just going to transfer here so you guys can see it better. It's the same circle, just without all the fluff around it, okay? They want me to solve for a CD, so that is X, all right? Now, I'm going to draw this a little imaginary line CE, because then look, what does it form, okay? That forms a right triangle, and we know how to solve for right triangles. We either can use trig or we can use Pythagorean theorem. So if I'm trying to find CD, I need to figure out what the measures are for CE and for ED. And I have enough information to already tell me what it is. So look, if EF, it told me chord EF is 8 inches. Okay. What are these two chords doing to each other if they're perpendicular? It bisects it. So if this whole thing is 8, then ED is 4, which I'm going to show below right here. Okay. Now I can also see what CE is. CE is a radius of this circle. So if I look at, I know this whole diameter is 18 inches. Once again, if it's being bisected here, then if the whole distance is 18 inches, I can find CB, which is also a radius, and I could say that it is 9. Okay, CB is 9 inches. So if radius CB is 9 inches, so is radius CE. Radiuses are radiuses are all the same. They're going to be the same length because they are the same distance from the center point to the circle. So this is going to be 9. So if you look down here now, I have my measurements. I'm solving for CD, and I know that CE is 9 and ED is 4. So hopefully you can see already what we're going to have to do to get X. We are going to have to use Pythagorean's theorem, okay, which is what I do right here. All right, now CE is my C squared in Pythagorean's theorem, right? And CD and DE are the sides. Okay, so this is how I'm setting up Pythagorean's theorem right here. I don't know what CD is, so that's going to be my X or whatever you want to call it. ED is 4, CE is 9. 4 squared is 16, 9 squared is 81, and I still have this CD squared bringing down. So now I'm going to subtract 16 from both sides, and I get 65. And then here, I have to take the square root to get rid of that squared. So the length of CD is actually the square root of 65. Or if you punch that into your calculator, usually when we work length, well, no, I hate to say that. Never mind. You could have left it as the square root of 65, or you could have punched it in your calculator and rounded it 2 places. Okay? So using this example, I want you to do example 4 on your own because it gives you the answer. The answer is C. Okay, but still, we're going to just draw this little right triangle. And they've given you enough information to know the lengths of at least 2 of the sides of the triangle. So do that on your own, okay? All right. Last concept, and this is the last theorem for this section. It says, in the same circle or in congruent circles, two chords will be congruent if and only if they are equidistant from the center. That means that if the two chords are being shown as being the same distance from that center point of the circle, then the chords are congruent. Now you have to see that they're the same distance. They have to tell you or show you, okay? So if two chords are the same distance from the center of the circle, then the chords are congruent. Here's your visual, here's the explanation. Put that in your cheat sheet. And now let's look at some example problems, okay? All right, so here, it tells me in circle P, EF is equal to GH, and they both equal 24. So right away, I already know that those two chords, EF and GH, are congruent. So if these two chords are congruent, then that means they are the same distance from the center. So if I'm solving for X, I'm just going to set 4X minus 3 equal to 2X plus 3 and solve. So here's the problem, here's the solution in 2 different slides, okay? So this kind of worked backwards from that theorem. All right, here I knew the chords were congruent, so I know that they're equal distance from the center, and I would set them equal to each other. All right, and there's your example problem that you'll work on your own, okay? Just read it. Same thing, all right? And now here is your assignment. Work these problems, show all work. I have to know that we're doing our work. And if you have any questions, let me know. I'm going to send out another just reminding everyone how to turn in their assignments. And then I think we're going to be well on our way. I hope these tutorials help. And I do miss y'all so much. So please stay safe.